Hey, good afternoon. I'm Rob. I am that developer dad. It is July 4th, 2024, and this is my afternoon streaming session. Excuse me. This morning we started building out some of the tests that we want to be able to run on demand for our dice rolling component, and we got a few tests written, and towards the end of the stream I realized that while those tests, yes, they're passing, they're showing that it does all the right things, but because rolling dice is inherently non-deterministic, that the fact that our tests are passing feels to me a little bit like luck. Like literally it's a roll of the dice whether or not the method is going to be invoked and return what we expect every single time over thousands and thousands and thousands of dice rolls. So I want to see about improving that particular test class so that it can automatically generate a couple thousand test cases and then just rip through them very, very quickly without me having to write thousands and thousands of individual test methods, because that's crazy and a waste of my time. So I looked up how to do a little bit of this automation after this morning's stream, because I haven't worked with XUnit a whole awful lot. My roles don't typically have me writing a ton of frontline code, so I'm not really in the habit, and I don't have the muscle memory behind XUnit. But in this case, I do absolutely want to use some unit tests, so I'm having to review some of the techniques and some of the basics. And I found a way that we can actually create a collection of tests that will be run against the same method over and over and over again, or perhaps even multiple methods where we're looking for different conditions from those invocations. So I'm going to pull my stream monitor off to my other machine before I start sharing my screen. Otherwise, we'll get the nightmare reflecting infinity mirrors going, and we don't need that. And so I loaded up the preview requirements. The number of dice might be different. Great, we're accounting for that. The kind of dice might vary for each instance. Okay, that's great. We may apply modifiers to the result. We haven't started dealing with that yet. And we'll get to that soon, but I want to get our dice rolling itself without any modifiers or special stuff. I want to get that proven, and I want to know it's going to work for me before we start adding the more advanced functionality. And then, of course, there's rolling with advantage, rolling with disadvantage. That, again, we're going to have to revisit that, because I think that might require a slight design change. And I'm not certain yet, but when we get to that point, we'll talk through it, and then we'll do some experiments to see if we can come up with a solid design that can account for rolling for advantage or disadvantage. There's other cases in role-playing games where you might have some feat or ability or something that allows you to re-roll any ones that you get on the dice, and then you have to take the second result, or things like that. And we want to be able to account for those in our dice engine. But as time goes by, we will extend this thing, we will expand on it. And if we do these initial design things right, when we go to add new capabilities, we're not going to have to change anything that we've already written. So let's get back to our DiceBag tests. Let's review these real quick. So we know that the DiceBag exists. Great. We only have to run that once. We're just testing to make sure the constructor ran properly and that our instance doesn't have a null value. Number two, whenever we roll dice, we always expect the result to be positive, at least when we're unmodified. Assumption number 3, the result of an unmodified dice roll must be at least equal to the number of dice that we rolled. And I'm going to change this to unmodified, not modified, unmodified roll. Is that all spelled right? Yes, it is. Must be at least equal to the number of dice we rolled. DiceBag roll must be no more than the number of dice times the sides on the dice. And this again, let's change this to unmodified. There we go. And then we always expect the number of dice to be rolled equal to the number of dice. Expect number of dice. That's named fine for now. We're going to add a variation of this later on when we get into dealing with advantage and disadvantage and stuff like that. All right, so we're going to save this. Now, right now, all we're doing in each of these tests is we are hard coding the number of dice and the type of dice. So what happens if I want to test a D20 as well as a D2, or I want to roll 3D6, and all of these different tests? I would, if I left things like this, I'd have to write individual tests for each of those things. So let's start off by parameterizing just this guy, this one. The expect dice rolled equals num dice. And I've got a helpful article up about making parameterized tests over on my other monitor. And bear with me for just a second. So when we want to parameterize our tests, we need to turn our fact into a theory. Save that. These should all still run. Let's give that a shot. And while we're working in this stuff, we don't really need to worry about dice tray tests because we're not going to be modifying those. And of course, as soon as it built, having changed fact to theory, we get a compiler error. And what does that say? Theory methods should have parameters. Okay, let's do that. And let's say int dice count. And let's just start with 1. Int dice count. And we got the little yellow wiggly. It's not happy. So int number of dice equals 6. Let's get rid of this. We don't need that anymore. And we got rid of the variable before we went and changed the things later in the method, because getting rid of the variable helpfully lights up all the places that we need to change. So let's just copy dice count, paste it here, paste it here, save it, and we still have a compiler error. And it says theory methods must have test data. Use inline data, member data, or class data. Okay. The helper article I have up on my other screen, it's talking us through using inline data, so that's what we're going to use right now. We're only going to use it for a second while we demonstrate parameterizing our test methods. So let's add inline data, and we're going to pass in 1. And then of course we can, if we want, copy this, pass it again, say 2, and copy, paste, and say 20. We could copy and paste until our fingers fall off. And that's great. We see that we got rid of the compiler error. Let's go ahead and run our tests and see how this behavior changes. I'm going to actually pull, let's hide our Explorer view, and let's pull this over here. No more than num sides. DiceBag exists. Okay, so these are all still just boring old standard tests that we've hard-coded. Our expect dice rolled equals num dice. That's got a little arrow here. And here we see that they all worked just fine. So let's run those. And those all worked. So great. We just extended the number of ways we're testing this particular assumption to 3 new ways. And we didn't have to write that much more code. Now let's change the kind of dice, just for giggles. MathRock kind. And let's say, we'll just call the variable MathRock kind. Okay. Now we see that we broke our inline data. Excuse me. MathRock kind isn't used. We no longer have to declare this variable. Goodbye. One of my cats is hunting something and thumping and bumping around in my house. So there's that. We fixed that issue, but now our inline data is no longer correct. So let's add MathRock kind. Oh, what are you doing, IntelliSense? Dot, let's say a D20. Cool. Inline data, let's say D10. Nope, it doesn't like that. D10. Nope. MathRock kind dot D10. Now let's say for this one, MathRock kind, somebody cast a giant fireball at level who knows what. We're going to roll 20d6. And we no longer have any compiler errors. Let's save and rerun our tests, just to make sure we didn't break the tests. All right, so it looks like, and I wish this thing had output the actual and expected results. Oh, here we go. Oh, it doesn't. It only tells us the parameters that it passed in. But that's okay. I really wish it gave us the results. Is there something I can do here? Nope. Again, I miss Visual Studio. Because it's got a really nice test explorer that allows me to iterate over each of these and I can see the results. Although that ultimately doesn't matter here. Because all we're doing is straight Boolean testing. Yes, the test passed. Yes, the test failed. If I were doing exploratory testing, where I actually want to see the results of the operations and so on as the tests execute, I'd want something a little more robust than this. And I'm sure there's an extension for Visual Studio Code that would give me that capability. Anybody that sees this, or like sees me doing this live, or sees this on the archive video and knows, oh, I use this extension, please comment, let me know. I'll install it right away and hopefully it'll make my life easier. So back to topic. We've added 3 tests here, and that's pretty good. But it's not good enough, because I don't want to have to do this nonsense. For every single test in this class. And B, I don't want to have to write, if I want 100 different versions of this test, I don't want to have to add 100 attributes. That's a pain in the neck. So another thing that we could do is create member data as a property on our test class. And that'd be okay. But again, over here, what they're doing is they're setting up an IEnumerable of object arrays called test data, and they're passing in the values. But they're writing each line of code manually, and that just looks like a giant pain in the neck, and I don't want to do it. So further down, I found this class data attribute. And what this does is it allows us to define a custom class that inherits from IEnumerable of object array, or IEnumerable of array of objects, or object array if you want to. Yeah, let's just call it object array. And we can define methods that populate that IEnumerable so that we can then pass it to our test methods. And yes, they're hard-coded yield return new object things here. But I suspect that we don't necessarily have to do it this way. We're going to use some dotNet collections to do this. Let's come up to the top. And I don't normally like putting multiple classes in the same file. But because this is a test class, and this class that we're about to create really only matters for our DiceBag tests. DiceBag test data. And let's go ahead and have it inherit from IEnumerable of object array. Escape that. It's being really grumpy here. The non-generic type IEnumerable cannot be used with type arguments. I think it's being daft. Let's do that. Oh, I bet I have to use that. We'll save this. We'll get rid of that reference. Tidy that up a little bit. Save it. All right, it's still being stubborn, but I suspect it's the design time compiler just being a little pokey. Perhaps we'll get there. All right, it still failed. Does not implement interface number. Okay. All right, we have a different error. Good enough. So let's go ahead and implement it. Boop. Get enumerator, get enumerator. Why is it doing each thing? Oh, okay. I see why. We can replace this. Goodbye. Go up to the end. And we're just going to chain the non-generic IEnumerable.getEnumerator to our getEnumerator method. Now in here, we want... I don't necessarily want to do yield return new object. I don't think. Let's see if we can list of object array test cases equals a new list of object array. Return test cases dot as get enumerator of object array. What's that complaining about? Non-generic method list object array get enumerator cannot be used with type arguments. Fine. We'll get rid of the type arguments. And let's just do a very simple test cases dot add new object array. And it's not going to be 1 and 2, it's going to be 1 and math rock kind dot D8. Okay, so we'll add one of those. Let's add a couple more. And we could just copy and paste. Let's add a 3 D6 dot add new object array, and let's say 2 math rock kind dot D12. Save. And it's D12. Here we go. Save that. So we've got our DiceBag test data. Let's roll down to the bottom again. And instead of using inline data, let's get rid of this guy. Replace that with class data. Is the XUnit keyword. And we're going to tell it to use a class that is the type of, what did I call it? DiceBag test data. All right, I'm going to save it. I'm going to build just our tests. And it's going to build its dependencies too. It's building, restoring, all that stuff. Let's rerun everything. And everything worked. That's fantastic. And if we hover over these guys, eventually it pops up and it says, we rolled 1 D8. On the next one, we rolled 3 D6. The next one, we rolled 2 D12. And that makes me happy. So let's go ahead and apply these changes to the other tests that we want to run multiple times. We're going to be using this exact same set of code here on each. So I copied it into my buffer. We'll paste it here, back it out, and now we have to fix our warnings. I'm going to hide that off to the side. And we're going to have int number of dice and math rock kind, math rock kind. Go all the way out to the end, and for some reason it lost my stuff. And int number of dice is already declared as a parameter, so we can back that out. Mathrock equals mathrock kind.d2. Let's get rid of that. And let's change the mathrock kind parameter name just to mathrock. I'm feeling lazy. Here we go. All right. And so we've just modified that one the way we need it to be. And we have tidied up our stuff. All right. Let's do the same thing up here. I'm going to copy this, paste it over the top of this. And what did we call our parameters? I'm just going to hide these extra panels because my stuff's getting a little long. This is something that you'll run into as you're writing test cases. I tend to use very long and descriptive method names. So to make things a little bit easier to read, I'm going to do something that might seem a little weird to some people. And I'm actually going to put the parameter list on the next line. In C#, that's perfectly legal. You can do this. I don't know how other languages might react to doing this. Now, int number of dice. Math rock kind, math rock. And we can delete these two variable declarations. Nothing else has to change. Up here, DiceBag, roll one, math rock, expect positive. You know what? Let's change the name of this test to unmodified roll, expect positive. I think I still have the new attributes in my paste buffer. I do. Int number of dice, math rock kind, math rock. Rip those out, save it, bring our test lab back, and I should probably rebuild. We'll build our test class again, or our test project. And it's almost done. There it goes. Doing the thing. Good. And we can see over here on our test list that all of those test methods have become theories. And that each of those theories has 3 actual tests against it. Let's run it again. And is doing its little build dance and all of that stuff. Oh, we have test results down here. Gosh, if only I'd opened my eyes. There's the right spot to grab. Okay, those are all the runs. I don't care about those. The test run did not record any output. Let's just close all those. Oh, ha. Let's run them again. I don't want to debug. I want to run them again. Give me some test results. Here's the run. And can we look at it? You gonna let me see it? Oh, it just runs it again. Ha! Okay. I wonder what that means. The test run did not record any output. I bet that becomes important when I want to automate things. Why didn't they run? That's so weird. Try it again. It looks like it's running. Here we go. Test results. Here it goes. All right, and we got all of these things. Unmodified role must be at least. Unmodified role must be no more than. It equals the number of dice. Expect positive. I wonder why. Oh, this guy's up here. All right. Reveal in Test Explorer. Here it is. Okay. Good deal. Let's close that down. Now that's all right, but we're still only running 3 cases per test. And that's not exactly exhaustive enough for what I want to do. I want to run add excuse me, for each kind of math rock, roll 1 through 10. X. We're going to put that at the start. Roll 1 through 10 of each kind of math rock. And make sure nothing fails. And hard coding all those tests is going to be a giant pain in the neck. And for each kind of math rock, well, our math rock is a type. So, type math rock type equals type of math rock kind. We're going to use a little bit of reflection here. Because if we come over to math rock kind, we go to the definition, we've got 1, 2, 3, 4, 5, 6, 7, 8. I don't want to write 8 separate loops, one for each kind of math rock, because what happens if I add a D87 or a D1000 or a bunch of other dice to my system? I don't want to have to come back in here and adjust my tests every time I add a new kind of dice to it. That's silly. So dotNet gives us this type system, and we know that the MathRock type is an enum. So we should be able to get an array of those. Var enum values, or enum members. Let's just call it members. Equals MathRock type dot get enum should be able to get members. That may or may not work. For each for num dice equals 1, num dice equals tests per kind, num dice plus plus, and tests per kind. Num dice has to be declared with a type. Tests per kind int tests per kind. Let's do 10. Because this is maybe gonna fail, probably, because I'm not using the correct reflection method to iterate through the members of an enum type. But I want to see, just because I'm feeling silly. Matter of fact, I know that's not going to work. MathRock type dot get enum names. That's going to return an array of strings. That'll do. MathRock names. For each string name in MathRock names, MathRock kind, current rock, equals and it's not get enum, that's silly. MathRock kind dot get I don't feel like get enum works. Dot. Yeah, we're Working with enums can get a little silly, and that's okay. I was gonna go searching for this in a minute anyway. Let's go search for it now. The random class, whatever. Let's go back to Copilot. And how can I, using reflection, dotNet reflection, iterate over each member of an enum type? Because that's what I want to do. And if I weren't doing this for demonstration purposes, then I could have just gone for it and gone in here. Var for each value in get values, your enum type. I don't want to do that. I just want to get the individual members. Names, value, enum.getValues, type of t.cast_t. I don't want the values. Yeah. That doesn't help me at all. That's silly. enum.getValues.cast_t. Oh, yeah, that'll work. That'll totally work. But I'm going to want to do a little bit of testing on that. So I don't think it's going to do exactly what I want it to do. I may not have had to use a reflection at all. Var dice kinds equals enum dot get values of math rock kind and dice kind. Well, what's get values give me? It gives me an array of math rock kinds. Well, jinkies. Let's not do this stupid reflection stuff anyway. Rename. Math rock names. For each. Can I? Okay, yeah, whatever. And I'm going to change this to rename. Math rock kinds for each math rock kind. Math rock. Ah, fiddle-dee-dee. And we're going to add test cases dot add new object array. We're going to pass in our num dice, our math rock, and I spelled that wrong. Using the wrong kind of brackets and wigglies and stuff like that. That could be simplified. Collection initialization could be simplified. Whatever. Blah, blah, blah. So this should give us, we had what? 8 different kinds of math rocks or something like that. I'm going to drop a breakpoint here and I want to see how many of these we have. And let's save all of this. Let's load our lab. And let's open DiceBagTests. Let's debug this exact test. This expect dice rolled equals however many. And I want to step in and see what's going on here. It's thinking. It's thinking. Come on. You could do it. We got a breakpoint out here. Have we hit at our breakpoint? We have not. Is it at least trying to run? I just want to debug this one. Debug that test. Will it even step into there? It looks like it will not. Okay. Well, that's weak. Well, there's only one thing to do, and that's let's run them all. See how long it takes. Let's run all of our DiceBag tests. All of them. All who knows how many. See how long that takes. Well, it ripped through everything in about 11 milliseconds. Neat. Pull that over here. Let's take a look at our test results. At 146. Look at this. 6, 4. And it looks like it ran them in parallel. And that's okay, because we don't really need to zip through. We don't really need to see all of these in order. But we can see in this test run that we had so many tests. So many tests. Let's reveal that in the Test Explorer. Oh, it's around here somewhere. So we've got all of our theories here, and I wonder if it'll give us sort of a roll-up of how many. No, it doesn't. Excuse me. But we can see that we're exercising this thing pretty darn heavily. And it's doing a whole lot of parallel processing. And we've just added, I don't know how many tests. We could do some quick napkin math. So we need to know how many math rock kinds we have. Excuse me. So let's go here and let's just count them up again. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 different kinds. For each of those kinds, we're adding 10 tests. So that's 80 tests, or 80 sets, 80 individual pieces of test data. And then we're using that test data on 1, 2, 3, 4 different tests. So that's 320 tests. Is that good enough? Nah. No, it's not. Because for each count of dice and each kind of die, I want to add a number of iterations. I want to test each combination a predetermined number of times. Now, I could just add another nested loop in here and just add each additional run of each combination in turn, but that seems a little off. Yeah, it'd be efficient, but I don't think I want to do it that way. Instead, I want to modify my test cases, first off, to say roll, and we're going to say int rolls per run. And we're going to default that to 1. So what do I want to do with this is rolls per run. Here we are calling roll exactly once. If instead, and we're reading the result of that roll into our dice tray variable. What if I create a list of dice trays test run equals a new list of dice trays. And then instead of just doing this, I wrap that in for int run equals 1. Int run equals 0. Run is less than the number of dice. Bump run by 1. We'll move that line up inside our loop. Test run dot add dice tray. All right, so our dice tray dot result is greater than 0. That worked when we had exactly 1 dice tray in our test run. Instead, we're going to use some LINQ. LINQ is spelled L-I-N-Q, and it stands for Language Integrated Query. And it lets us do some interesting operations over sets of data or collections of data. Now, our collection in this case is our test run variable. And we want to assert that test run dot dice tray dot result is greater than 0. So instead of overwriting that, I'm going to do this. I'm going to assert dot true test run dot all. R for run, R dot result is greater than 0. And what that line of code does is it asserts that all items in our test run collection have a result that is greater than 0. And we're testing a theory. Bool. Evidence equals let's do that. String theory statement equals all dice trays in our test batch have a positive non-zero value. Assert.true, and we want to assert our evidence. And do we have any overloads? Oh, we have some overloads. Condition, then a string. So we can add our theory statement. Save that. I want to run all these DiceBag unmodifiable expect positives. Right now we're just running it with our rolls per run equals 1. Can we run this exact test? Yeah, here we can. Run test at cursor. Do it. It's going, it's running, it's testing, and now we got to find the one that we ran. Is it still running them all? I can't tell. Unmodified expect positive. Well, here's all of these. So I guess we're going to have to run this whole batch. Do it. Here we go. So rolls per run is true, and it looks pretty all right to me. Go to test. Okay, we went to test. All right, now, so rolls per run is coming in like that. Real quick, because we're getting close to the very bottom of the hour. Let's add this kind of logic to our other tests. So I'm going to grab all of this stuff, because this is all under act. We're going to have to modify this for each thing we go through, but that's okay. Oh, we're going to need this too. I'm going to move this up here because that's under a range. Excuse me. Goodness. I really ought to quit smoking. And let's copy this. Our code down here is very similar. I'm not going to overwrite the assert completely, but I will grab this and paste that. Did we copy test route? No, we didn't. Nope. Z. Let's go make sure we've got the right amount of stuff in our test buffer. Here we go. Copy that. Come down here. Highlight all of this. I want to leave this alone for a second. Do that. And our evidence, test run.all, our results is greater than 0. This is actually what we want to use here. So we're going to copy that and paste this. And instead of dice tray, we're going to use R. Then we're going to get rid of that. Goodbye. Save that. And all dice trays in our test batch have a result. Have a result equal or greater than the number of dice. Save. Let's update this guy. Unmodified roll must be no more than that test. And our expected is this. So I need to do this. Highlight that. We're going to paste over the top. Nope. Let's come up here and grab this. Copy. And I'm going to highlight this and paste. There we go. Much better. And all dice trays in our test batch must have a result at or below the let's use some string interpolation. Expected. And assert.true. Test.run all. Okay, this is r.result is less than or equal to expected. And now we can replace our assert with evidence theory statement. Save. Pardon me. Now our test runner was talking something about no output from the test run, and I'm really curious about that. So we're gonna dig into that in a little bit. Maybe not until tomorrow. I'm gonna dig in personally and find out how we can get these test runs to actually give us some maybe actionable results. And we've got errors all over the darn place up here because run is less than number of dice. That's not right. That's not what we want. I'm going to have to go through and fix all of these things when I add the new parameters. All right, let's get this one down again. No more than x times sides. And expect dice rolled equals num dice. This one, I don't think we need to, pardon me, include our, or account for the number, a number of different things, because all we're doing is we're making sure that if we pass in a test run that asks for 8 dice to be rolled, it rolls only 8 dice. We don't have to run that 10 times for each kind of die. That's silly. So we're not going to modify this at all. But we do want to collect these because we actually care about the results. And it's going to be int num runs. We'll default it to 1. Num runs. Come up here. We need to add it here. Whoops. Int num runs. Give it a default value just so that we don't break our stuff. rolls per run. I actually want to use that. And I actually want to rename it to rolls per test run. We're not even using it. Ha! There. Rolls per test run. Num runs. That doesn't really give us much information about what that variable means. Right click. Rename. Paste. Do it. And then our last one, we're not going to mess with that at all. We need to come up here and add. We've got tests per kind. I want to add one more variable. Int rolls per test run. Let's say 10. We're about to go from 320 to 3,200. Per test run. Every time we hit run test or run tests for this class, we're going to be running over 3,000 individual invocations of DiceBag.roll. Let's see how long it takes. Before we do that, let's rebuild. I don't have any Python tests. What even are you talking about? Build your C# project. Oh, it's still building. My poor little Mac. Here we go. So it says 80 of 80 because we still have, 80 of each of these. 80 individual things. 80 individual combinations. And then we multiply that by a lot. Let's see what happens when we run all of these. So right now it's building. Again. Oh, we got a invalid operation exception. Expect dice rolled equals num dice. Oh. Okay. So it's going to pass all of these values in every time. But even though we don't want to use it, we have to let it be passed in. So int num runs in test equals 1. And what I'm going to do up here is just add a note. We're not going to use the num runs in test since we're counting the number of dice rolled equals expected, we don't need to worry about random numbers affecting this result, this assessment of the operation. Let's rebuild. Let's go. We're up to 774 discrete runs. And did it all vomit on me again? Test method expected 2 parameters, but 3 parameter values were provided. Did I not save? Oh, I must have to rebuild. Dang blasted. Let's refresh the tests. Come on. Doopy doopy doo. And yes, everybody struggles. Part of a shipped public API. Yeah, no, shush. Go away. Go away. We don't need that. Fix formatting. Nope. Go away. All right. Let's rebuild this class one more time. And then we're going to call it for the day once these guys are working. Because we'll have found ourselves a stopping point. It's still thinking. I don't know why it thinks I'm building Python tests. I mean, I've got the Python things loaded. All right. Let's just run our DiceBag tests. Run them all. And see if it still complains about getting too much data passed to it. All right, we've got 321 tests all running correctly. Let's run everything. And it's rebuilding each time it does it. 324. Okay. And that actually makes sense. We only have 324 discrete tests, but within 320 of those, we're actually calling into our DiceBag. We're calling this method like 3,200 times. We could do it 32,000 times by changing a 10 to 100. Let's go to 320,000 times. Save it. Refresh. And then once this is going, I'm going to do some research on getting output from our test projects. So we've still got 324. Refresh. I think there's more than that now. Go. Yep, it's counting. It's counting big. And most of this time is taking... Oh no, it's running them too. We've got all these tight loops and all of that stuff. And in total, we just ran 3,200 tests because we wanted 100 individual test rolls per kind of die. And that means we were rolling between 1 and 100 of each of those dice. And for each combination of the number of dice and the kind of dice, we're rolling that 100 times. That ends up giving us 32. So 3,200 times 100 is 320,000 tests run in less than 25 seconds. Most of that was setting this stuff up, and we could probably do some tricks with like parallelism, and we could probably even do some things like getting rid of this constructor call in each iteration of the test. We could probably set this up and get rid of our constructor. We want to keep this new test run here, but we could make some efficiencies here to make our automated tests run in less than 25 seconds. But we're getting into some diminishing returns there, and I don't necessarily think we want to optimize like that. Show me a QA team that can run more than 250,000 tests against a single function in less than 25 seconds manually, and I will show you a QA team made of robots. So that's just sort of a ridiculous example of how powerful some of these automated test concepts can be. Let's bring it back down to something a little more reasonable. Like, let's only do between 1 and 10 dice at a time. But let's go ahead and keep rolling 100. Nah, let's do 1,000. So that's going to give us 10,000 times 8 is 80,000 per experiment. That's still 320,000 experiments. Let's knock that down a little bit. Yeah, we'll just do 100 per test run, and that should be sufficient for us to have faith that our DiceBag is working the way we want it to. That's it for me. I got to go do some other stuff. 2 of the kids are coming by with, our oldest and his wife are coming by, and our middle kid moved in with them a couple of weeks ago, and they've spent this week out in the mountains of North Carolina rafting and camping and having a great time, and they're on their way home to Raleigh and are going to pop by for a visit any minute now. So with that, I say thank you for joining me. For those of you who are watching today, happy 4th of July. For those of you who are catching me later, it was 4th of July when I created this, when I did this stream. So I hope whatever day you're having is good. I am that developer dad. Take care, and we'll pick this up again tomorrow, extending the capabilities on our DiceBag. Have a great day.